Hi, Paul.
Hello. So this is a joint session. I'm Paul Stack. This is Lynn Langit. I'm very, very privileged to actually be doing a co-presenting session with someone whose stuff I follow really well. So this is awesome. So thanks for doing this. This is like a cloud DevOps talk. We are going to be building some cloud systems. It's mostly demos.
Yeah.
So as we go through it, we'll hopefully just fire lots of questions at us. We may run slightly over now because we're a little bit late, but just keep interrupting with some questions as you go.
And I don't work for anybody. I work for myself, and I have an MVP from Google, Microsoft, and Amazon. And so I love to give my opinion about things, so feel free to ask, okay? Feel free to ask. So I'm going to let you get started, yeah?
Okay,
and then we'll switch in the middle.
Cool. I do work for someone, but I'm still quite opinionated. Okay, so the first of the demos I'm going to do is just based on Azure. Any Azure users in here? Yeah. So I'm just going to build some basic compute examples in Azure. I'm going to use a tool called Terraform. Anyone know Terraform? Some people. So I work for the company HashiCorp. This code was written pre me working for HashiCorp. So this is not a best practices way of doing it. This is a getting stuff done way of doing it. So there we go. So when you're writing some Terraform code has its own DSL. Okay. So because of the DSL that it creates, it's very simple to read, and it's not using large JSON files. So those who use CloudFormation, you have the JSON content for the cloud templates, and those again who are using Azure Resource Manager also have the JSON templates. Okay. HashiCorp decided that maybe JSON wasn't the correct way or the easiest way for developers to have to write this type of code, so created small composable resources and segments, pieces of information called resources, and then that way they could pass information between them, and under the hood it was taking care of it. Terraform actually is based on graph theory. So Terraform will actually understand the graph and the order and the operations that the cloud providers need in order to actually build the application. So for example, I declare an Azure resource group. So this is using the Azure RM, the resource manager. It's not using the classic system, so it's using the new portal and the new features. So everything goes inside a resource group. We have some variable interpolation in here. So we pass in a location. Location being like Southeast Asia, Australia West, Australia East, Central US, etc. Okay. We can then declare a virtual network, pass in a name, address spaces. Again, we're passing in the location so that we can understand and we can actually make it unified through it. But then on line 12, we're actually referencing the resource group. So this is helping Terraform understand how to build the graph. Okay. We're actually saying at this point, this virtual network is dependent on the resource group declared above. So this variable interpolation syntax allows us to be able to use the computed values that are created as part of the resource group and that come back from the API to be used in other locations. And I'll show you when we go into AWS how that works even more fine-tuned, because there are a lot of values that come back from the API that you don't have to set, but that are very useful to be stored elsewhere. Then we declare some subnets. We declare a storage account. Change the name of that storage account because the other one exists at the minute. And we have containers inside the storage account. And then lastly, we're going to create some scale set machines. Okay, so scale sets in Azure are the equivalent of AWS autoscaling groups, for those who don't use them. This allows us to specify a number of machines, and Azure will keep the health at that level of machines. So if you drop one of the machines and one of the machines dies, Azure will spin up a machine in its place. So now we start to get into some interesting stuff. We can have nested resources or nested information as part of our resources. Okay, so we can have an SKU, so the size of the machines. We can have the OS profile, so like the admin username, admin password. This is unfortunately one of the areas that Terraform suffers in. This is a plain text password. This is not great. There are current implementations and current work underway in order to stop that. HashiCorp does make a secret store. It's called Vault, and it's fantastic. Terraform has currently no integration with Vault.
Yeah,
It currently has no integration with it. It is in the works. I know. And there are a number of tools that people have actually written in order to solve this problem. So a company called OpenCredo, who are based in the UK, have written an encryption engine for Terraform, so that as soon as you actually run your Terraform scripts and it creates the state file, it will encrypt your state file for you. So it is being worked on, and we know that it's a grave concern, and it's something that a lot of people, even internally, are thinking, hey, we need to do something about this pretty fast. We have a network profile. Then we're actually going to store some disks. In Azure, when you spin up a machine, it's not like EBS in AWS. Okay? It actually will store the disk as blobs in your storage account. So you have to specify where you want the machines to store the blobs. And if you obviously need to delete the blobs, then the machines will disappear. Or if you do delete the blobs, then the machines will disappear, which is not fantastic. And lastly, we're going to use 16.04 for this, Ubuntu 16.04, and see, this is obviously Xenial, this is the new Ubuntu that we can spin up. I have commented out for those when you go to the website, or when you go and download the source code for this, there is Windows work in here as well. To spin up a scale set of Windows takes 30 minutes. I don't have time for that in this demo, but you can go and you can download the code and you can try this out in your own storage account, and it should work okay. It does work okay, should I say. So inside Terraform, we can run the command Terraform plan. Excuse me. Terraform plan. Terraform plan will take a snapshot of the state locally. So it will work out and draw the graph locally, and it will compare that graph against what is in the cloud provider that it's trying to manage. And it will give you an output eventually. And it will tell you what it's going to do and how many pieces of information it's going to change. It will give you the full output. Okay, you can go and have a look at it and see whatever you want. The nice thing about this is because we have a graph, we can actually map the graph. The graph allows us to start to picture our infrastructure so we can see how to do it. So I'm going to run the command Terraform graph, which will give us a load of garbage out. This is of no use whatsoever. We can pipe that through a package called dot on OS X, or there's other ones available on Windows. And we can save it as a PDF or a graph or whatever. So where I use this is every time I make a change to my infrastructure, I save a snapshot of the image so that I can see how it's changed, which is, this is my living documentation. And as I make changes or adverse changes, I can quickly reference and say, hey, what's different between these two systems? Because it's very easy to look at an image and say, something's missing, or the dependency tree has disappeared, so therefore we can't talk, and we can't talk to our storage account.
Can you get to show deltas?
No, is the answer, because it's a PDF. I have not been able to manage to get, excuse me?
Get the graph command to show
I'll come back and I'll show you how to create a delta output, okay? 1 second. So let's open the graph, and we can see a tiny little image. Okay, this is a very simple infrastructure, and as we go into the AWS one, we'll build out a much more complex infrastructure. So the virtual machine scale sets depend on both the storage container and the subnet. There is no dependency between the subnet and the storage container, so they can be created at the same time. The storage container depends on the storage account, and the subnet depends on the virtual network. Again, there's no dependency between them, so they're in different trees of the graph and can be created at the same time. Everything is dependent on the resource group. So what this is telling you is that the first thing to be created in this entire infrastructure is the resource group. Then we can create the virtual machine and the storage account. Then we can create the storage container and the subnets. And then lastly, when all of that is in place, we can create the scale set. Any questions on that? Awesome. So let's run it. So I showed you the Terraform plan. Okay? Terraform plan can actually be saved as an output. And that's where you do your deltas. Okay? Because you're saving the plan of the output, and then you can actually compare the plan against what the current state is, and that will actually show you what the delta is. So Terraform apply. It's a little slow on Azure because it's making a lot of network requests under the hood. Like a lot. somebody actually benchmarked this using charge proxy on an airplane Wi-Fi. And it made in the region of about 2,000 requests in order to build a skill set. Because they have to register providers, and there's a lot of content negotiation going backwards and forwards. In AWS, their model is different. So it's not, I'm not saying that this is worse, but it's different in how other clouds are working. But what you can see is it's created the storage account, creation complete. Then we can see it's creating the virtual network. At the same time, it's creating the storage account. So they're happening in parallel. And you can see all the computed values. This is all information that is available to us that come back from the API. Once the creation of the virtual network is complete, we can start to create the subnet, the subnet. And lastly, once the storage account is complete, we can start to build the containers, and then everything will kick in and allow us to build the virtual machine scale set. So if I go to the portal, the very awesome Azure portal. Has anybody used the portal? It's really tough. It's really hard. I love the scroll and write. You should read Lynn's blog on this. It's fantastic. So right now we can see that there's a virtual network, and we can see that there's a storage account. And if I refresh, you'll see that a scale set is now actually being built. And we can start to see that it's making its way down through the system. I'm really hopeful this will work. This worked earlier. If it doesn't work now, you can take my word that it works. So that's going to take a little bit of time. So we're going to swap across to AWS, okay, just because this will happen in the background for a few minutes, and then we'll mess around by removing some things, and we'll be able to see the diffs in what Terraform does right there. I think it takes in the region of about 3 minutes for that specific demo. So here we go. So containers. Anyone use containers? A few people. Containers are ridiculously hot right now, and everyone wants to learn how to build container architectures. This is not serverless. Okay, I'm not building microservices. I have a really simple container that is a hello world container, Nginx style container. And what we're going to do is we're going to actually build an ECS cluster. We're going to create the ECS service, the task definition. We're going to put it behind an ELB internally. And lastly, we're going to actually have like a discovery endpoint, which ties the whole thing together with a dynamic Nginx config as proxy pass through the system. So there's a huge amount of code in here, right? And we're going to take it a little bit at a time so that I can actually talk you through it. This code is available, so don't worry about like digesting it all now. Here we go. In order to use AWS, you just got to change the provider. Terraform ships with many providers under the hood. Okay, Google, AWS, Azure, DNSimple, VMware, vCloud, DigitalOcean, Joyent. There's lots of cloud providers in here. Okay, you can go and you can experiment with whatever you work in your day-to-day environment. In fact, if the tool doesn't support your provider, there's a video of mine online on how to write a provider. It's a shameless plug. We are going to declare a data set. This is new to 0.7, which was released Wednesday morning. And what this does is says, hey, go off to my AWS account, tell me the availability zones that are available to use within a specific region. The reason that this was created was that in US East 1, in AWS, different people with different accounts were getting different availability zones. Okay, because there's so many availability zones to use, you can actually only use 3, and Amazon will randomly give you access to 3 of them. So we thought, why don't we write a tool that will allow you to go to the cloud provider and tell you what availability zones are available within your account. We have a really simple key pair. And then we have a VPC. So we're going to create a VPC that has a root CIDR block of 10.0.0.0/16, the biggest CIDR block that we can give. Okay, it's got 65,000 IP addresses in it. We're not creating 65,000 services. We're going to have 2 private subnets and 2 public subnets because it's in Sydney, and the Sydney data center only has 2 availability zones. So we're going to just use that. Now, we are going to take the lookup of the availability zones available inside our account, and we're going to create our VPC across all of those availability zones. The data source lookup is new, but passing lists around within Terraform is now new. So before we would have had to take that, we would have had to actually convert it to a string, common delimited string, pass it as a string, and then in the other side we would have had to split it again by comma in order to create our list. So that was kind of sucky, so we thought, let's change it, and let's actually have support for passing around lists. All of this is wrapped up in a module. A module is a reusable piece of code within Terraform. For those who are developers, think of it as like a third-party API, like a library that you download and you write code against. And we can go and have a look at one of the modules. So the VPC is probably the most complex that I have. We have an interface. So it takes a name, a CIDR block, some public subnets, some private subnets, some availability zones. It has some outputs, which we'll come back to in a little bit. We have a route. We have elastic IPs. We have NAT gateways. This code looks a little bit more complex because we're using a lot more interpolation of the system. We're passing variables in, so we have to access the variables using things like element and length and counts and indexes. But because this is hidden away in the module, as a developer, you may not care. In my last role as an infrastructure engineer, I used to write these modules, put them on our GitHub at the company, and allow the developers to download them as part of the module source, and they would just write them. So the developers only cared about a VPC that worked. They didn't have to care too much about the internals of the VPC. And that was very key. It was really useful because as an infrastructure engineer, we had a lot more power and a lot more control about what they were building.
So it's abstracting away some of the complexity.
Yes, it's completely abstracting away the information. Somebody asked me before, they were like, will a module allow me to be able to switch cloud providers? The answer is pretty much yes. Okay? If you can come up with a naming scheme, a proper naming convention between in the module that is generic enough among cloud providers, you could have a VPC and the equivalent in Azure being a resource, or a resource group, sorry. If you can create some generically named parameters, as an infrastructure engineer, you can change it under the hood. And as if your company has decided to go all Amazon or all Azure or change from one to the other, the developers, again, don't need to care. They just need something that works and something that they can test their systems on. So back to the rest of it. We're going to have an AMI. Okay, that's Amazon's machine image. So we're going to use a pre-baked Amazon machine image in order to spin up our ECS cluster. Okay, this is the cluster of machines in which we're going to deploy our Docker images, our Docker services. Okay, we use the AMI. We give it a cluster name. We give it some specific size and an instance type. And then we can actually say, hey, look, I want to create this ECS cluster in the VPC that I have declared above. So the data that is coming back, the ID, so if you go to Amazon, you'll get an ID like VPC-1234567. You can get that information back, and you can supply it to the next module down the tree in order to build that tree and say, hey, take it and build it in that system. We're going to create a Bastion node just because in case anything goes wrong, we can SSH in and we can have a look around. And then we're going to create a service. This is where we get into the real meat of building our application itself. For those who've looked at ECS services, you've got to do all sorts like build JSON templates and task definitions. I thought it would be really good to be able to abstract that away. Okay. I don't want people to have to create JSON. I will create a template that they can plug values into, and the JSON will be created for them. So the first thing is a service. We want one instance of our service. It's going to go in the cluster we created above, and it's going to have the IAM role, so the access and identity, from the cluster that we created above. Now, the access and identities I'm not going to go into because that could be a whole talk in itself. What it allows us to do is to say, hey, this user or this service has access to launch an instance within the cluster, in a nutshell. We're going to create a service or a task definition called demo service, and it's going to use the Nginx Docker container, which is just freely available on the Docker Hub. We're going to give it a little bit of memory and some port. And then lastly, we're going to give it an ELB. If you have one or more Docker services or ECS services in the system, because they're dynamic, you want to be able to hit those. And you want them to be able to take care of the health checks for you. So we're going to put them behind a small ELB, and everything will be able to be tunneled through the ELB. We're going to take the output of that address, just so that everyone can see it on the screen. We're going to build a dynamic Nginx config. This is like, I'm going to say this is quite hacky, but this works perfectly. Okay. So if you have like 20 services, and you want to build a front entry point into your entire application, because everything is hidden away in private subnets, you don't want to expose all those addresses. You want a single entry point into your system. So we build a really simple Nginx config where we can say, listen on port whatever, the server name is whatever we want, and then the location of this URL, when we hit the endpoint slash, we'll call it Sydney, we're going to go to the Sydney ELB address. When we go to foo, we'll go to the foo ELB address, and so on and so forth. But because this is all using interpolation, we can take the outputs of all the ELBs that are created and dynamically build our Nginx config and inject it into our services. There's a question. I knew there was going to be a question here.
Console also, doesn't HashiCorp also make a wonderful product called Console?
They do. They do. This is not me trying to sell HashiCorp tools at all. Okay. And as I say, this code was all written pre me working at HashiCorp. The point of this demo right now is to show you that with a little bit of code and a little bit of simplicity, you can start to take advantage of using container services. If you want to go and install like a 3-node cluster of a service discovery tool, then that's great, because there's a lot of code out there and do it. But a lot of people will look at it and think if that's a real big overhead, and they may not want to do that. And then the last part of it is we have a discovery module. Discovery module spins up some machines, and ELB injects the Nginx config into it. So there's a lot of different pieces of code here. So let's have a look at what it does. Terraform plan. You'll see this should be quicker. It is much quicker. Oh, it worked. The Azure one worked. I'm actually quite surprised. I'm not really surprised. We're going to let that plan in the background for a few minutes. I'm going to show the Azure stuff quickly. If I refresh, I can go and have a look at what's in the scale set. And we can actually see that there are some VMs running. Way! Okay. So like some really simple declarative code, like really simple code, we are actually able to start building a very simplified infrastructure. You can make this as complex as you want. You really can. And what I can do is I can actually start going and go, hey, let's remove this virtual network. Oh, I don't want to delete the resource group. That would not be fun. This is one of the problems of the portal. You can delete some things, but you can't delete others. Settings. We're going to pretend that that works. The portal is quite complicated for some of these. What I wanted to do is actually delete one of these machines, but you can't delete one of the machines from the console. This is a new feature, by the way. This was released 6 weeks ago. When you created a virtual machine scale set, if you wanted to see the machines that was in it, the Azure documentation actually told you to go to the CLI and run a CLI command. There was no way of being able to see them in the console. So let's leave Azure behind, and you can see that there's a lot of provider support in there for all different things. Here's our plan for our service discovery and our ECS cluster. Okay, we can see that it's going to add 40 pieces of information. So Terraform apply. And while that's running, I'm going to show you the graph of this. The graph starts to become a lot more complicated. Okay? There's a lot of information and a lot of pieces of the puzzle right now. Okay? Because we're using things like IAMs, and we're using subnets, and we're using subnet associations, and we're using route tables, and we've got all of this information, but effectively it's drawing us a complete picture of the order in which of operations. Okay? Anything along the same level can all be created at the same time. The lower down, the more dependency it has. So it starts at the bottom and works its way up. And all the pieces of the system at the top level are all the pieces of the information that we require. This is not the most complex graph I have seen. Some of these graphs are ridiculous. Like the more network infrastructure that you manage, and the more pieces of the cloud that you manage, the more information that you can get. Okay. I'm going to include the graphs in the GitHub repo just so that people can see them, just because they're quite useful to see. And I'll drop in the README the commands in which to do it and what packages are available. But this is really quick. This is like creating ridiculously fast. Wow, it's going faster than I can hold up. So as part of the install, when it spins up the Bastion node, okay, so the node in which we can SSH into and then go all around inside our VPC, we want it to run some remote exec. Okay, it's an Amazon Linux image. Okay, Amazon Linux is usually very good at keeping up with the latest packages and the security updates. So what I want to do is just do the equivalent of like a yum update. Okay, just to make sure everything's working and all the package sources are all available. So it will Terraform, as when it spins it up, will wait for the machine to spin up. It will use the credentials that you have told it to, and it will connect to that machine via SSH and run any remote exec commands that you want. So this is where you can do like your Chef runs or your Puppet runs or your Ansible runs, whatever you feel, and it will take care of helping to provision your machines for you. Let me go and clean that up quickly. This is because I just tested this stupid thing. Da, da, da. This is just to show you that errors can happen. Let's delete those quickly. There we go. So Terraform has saved partial state here. Okay, it doesn't have to go back to the start and redo everything because it remembers that it has already created the VPC. It has already created the Bastion box. It has already created the ECS cluster. Now what it's doing is it's going to refresh the state of everything, and it's going to say, okay, where have I got to make the changes to bring the environment up to the same configuration? And it'll continue just churning its way through. Any questions so far?
Where does it save that state?
Oh, good question. Where does it save the state? So right now it saves the state locally, okay, because I haven't done anything else with it. There are many options in which you can save your state to. For example, S3 buckets, Azure, blobs, Google Compute Engine, Atlas. I'm hoping, I've heard rumors that someone is opening a PR that you can store your state in Vault, just because it's actually sensitive information. It would be really great to store it in there. But Artifactory is another one. So people create their own endpoints. It's just basically put and get in order to store the state when it's finished or when it's just about to make a plan. But the nice thing about it is that by storing the state remotely, more than one person can share that state. Because right now, if Lynn ran the same commands that I was going to run and didn't have the state, it would try and recreate everything again, and it would basically fall apart because you would create two VPCs with the same name and the same CIDR block. So if you're going to use it in a team, for definite, you must store it remotely. If you're in AWS, an S3 bucket that's versioned and encrypted is probably the best thing to do. And it's very simple configuration to do that. It's on the website and you can have a look. Right, it's working its way through right now. Let's go and have a look at what it's doing. So we have a demo cluster, and there are currently some instances being spun up in that demo cluster. It takes a little minute just for them to spin up and actually register themselves. So we have a Bastion node, we have a Discovery instance, we have an ECS cluster instance, and you can see that the ECS cluster instance is still initializing, so that's why it's not part of the cluster right now. Hopefully it'll kick in very shortly. Come on. It's thinking about it. I promise you. An instance for an ECS cluster is effectively a machine, just a tiny instance, and it has a Docker agent running on it, and you inject the name of the cluster, and it goes off and searches inside the system, each of the nodes, in order to form a cluster. Okay, so this is Amazon's way of doing it, and it seems to work quite well. There we go. We have a registered container, which is awesome. So now we're actually going to start getting the service. Don't worry about that. That's my fault. I'm refreshing too quickly, so it's trying to actually, it thinks that it's available because it's making an HTTP request in order to work out where it's at. I have like 4 minutes of this left, I promise you. And then you can get somebody who's going to show you something else. You can have a look at the state, actually, while this is happening, just so you can see what it's doing. So it holds the version of Terraform. It holds all the information that you want. You can mark variables as sensitive. If they're marked as sensitive, it won't store the actual value in the state file. This is very new. You used to get hard-coded passwords stored in your state file. And when people were checking their state files into GitHub and public repos, you could search them. The amount of people who check stuff into public repos and GitHub is amazing. It really is. So please take care of this type of stuff. We have a demo ELB address. We have a discovery address. And then it starts to register all the resources that we have, all the availability zones, etc. Everything is there. Okay, so we should actually have a service right now. Hopefully. Come on, service. It's really thinking hard about this service. This is very strange. Please don't fail. I'm currently getting 2.5 kilobytes a second. Any questions while this is running? No? Anyone just want me to get on with it? Right, this is bizarre. This is actually not creating this service for some strange reason. But you can see that it's actually trying to create the task definition of the service. And I don't know why it's not, but it seems to be stuck in a loop trying to create it right now. Oh, there we go. Ooh, excellent. So we have a service. That actually surprised me, that one. And if you go inside the service, you can see that it's we want one instance of the service. So it's currently trying to spin up an instance of that service. And this is like auto-scaling, but for your Docker containers. So you tell it how many instances it needs, and it keeps them running. You don't need to care about this, which is awesome. And we actually have a finished product. So the last thing is, we have a discovery endpoint. Terraform has, by the way, Terraform has outputs that you can actually put some very cool information into. Okay, so for example, I'm actually telling the user if they need to SSH into the Bastion, it's SSH EC2-user at. So you can use variable interpolation and formatting in strings in order to give really good information and helpful information for the users. So this is like the top level page, okay? But if we go to /Sydney, we're actually going to go through and proxy to another Nginx page, which will say the same thing. Damn it. Yeah. So what it's actually supposed to, it's a simple proxy path. Let me show you what the, stupid. Let me show you what the launch config does right here. And we can, I'll debug it before I give you the repo name. That is so funny. So the user data that we're injecting, we're just doing an install of Nginx, and we're just echoing out some configuration. And that's what it is right there. It's because I have an equal sign in there rather than anything else. So my Nginx configuration is incorrect, and therefore the proxy path won't work. But we're just injecting that in and saving it as like an Nginx config. So every time you add a new service, Terraform will regenerate that Nginx config and inject that in for your user data, so that when you boot, it'll allow you to create as many services as you want. I have one on my machine that I can show you at the end. I can't show it on camera, but there's currently 15 services on it. And you can see how it builds the full tree for the Nginx config. And with that, I'm just going to pass it over to Lynn. Any questions before I go on ECS? Excellent.
Can you switch the sheets?
These guys are going to switch.
Right, but can you physically put it?
Oh, yeah.
So as he's doing that, one of the things I always do when I come to a new location is I test the speed of the cloud. And so I did some research before I came over, and what I found is that your co-working space Fishburners, you guys heard of Fishburners? Supposedly had the fastest cloud in Sydney. So what I did is I went over to Fishburners last Friday and I tested the cloud, and for this particular scenario, just have to mention that the fastest cloud, strangely, doesn't appear to be in Sydney. It was using the Google implementation with the data center in Singapore. So Google is the inventor of the container technology. And what I find when I travel to different locations is if there's not a data center in the country, the cloud provider kind of tends to be ignored. And in some cases, that's valid. But I would tell you, based on my own testing, if I were setting up a cloud-based environment here, I would certainly look at Google. In terms of the scenario that Paul showed, I think it was kind of proved out. In terms of straight-up speed, Azure was by far the slowest. Amazon was in the middle, and Google was on top. Speed isn't always the only concern, but that was kind of the case with that. Now for mine, my talk's very much of a contrast to Paul's. My scenario comes out of my work as an architect, and I do a lot of bake-offs. And in fact, that's the name of our talk. And the bake-offs are often enterprise. I work with both startups and enterprise. And I'm going to take a very old school scenario, which is a data warehouse. And I'm going to show using the vendor tools, in this case, Amazon, so none of the fancy third-party tools, which are all good and great and very useful. But I think it provides like a contrast to show what can you get with the vendor tools. So the scenario that I'm going to show is a data warehouse, and this comes out of my own work, just setting up data warehouses in reality. And I did this as a workshop at reInvent last year, setting up a data warehouse in 2 hours. Just as an aside, if you might not be aware of this, but the Redshift product, which is it's a MPP, massively parallel Postgres implementation, is the fastest growing product in the history of Amazon. So I'm not the only person that likes the product. It's $1,000 a terabyte. Yeah, which is just stunning. So, and not so much this last year. This last year I was doing a lot of IoT, but in the 2-3 years previous, nearly 100% I set up Redshift data warehouses at customers because almost everybody could have a good use for it. It's just really, really simple. So the things that are different in my demo is, number one, I recorded it because I didn't want to rely on the Wi-Fi for loading an actual data warehouse. That just seemed kind of crazy. And number two, I'm showing using pre-baked AMIs that allow you to rent vendor services that load the data warehouse and visualize the data warehouse. So ETL tools and visualization tools. So in the one that I did in Vegas, I used Tableau for the visualization, but I got to know the guys from Yellowfin who are actually local here in Australia. So I did this implementation with Yellowfin for the visualization tool, and the load tool I worked with Matillion ETL, which is a small company in the UK that was a consulting firm doing Redshift, and they didn't find like an SSIS type thing for Redshift, so they built one. It's an EC2 instance. And I actually discovered them. I did some work with Amazon on the different vendors in the marketplace and brought them to the show, and they won Best of Show last year. So it's kind of cool, right? I mean, I feel kind of good about it. So Matillion is a really solid product. There's other ones out there. So what I'm going to do is I'm going to play my recording and kind of talk through it a little bit. And then I'm going to talk about the process for building up scripts using the CLI scripts and some of the tools that I use. I wrote all this in scripts. It's in GitHub, so you can see it. And then I'm going to show using CloudFormation, which is the Amazon tool that generates the entire solution formation in a JSON file. And you can check it in and check it out. Does it make sense? So that's what I'm going to try to work on here. And I have all my resources published. Everything is on my blog, which is lynnlangit.com. So if you're hungry, you can just leave now and go watch everything there. So, okay. And, you know, one of the things, probably, does anybody in here use the Amazon Marketplace? Yeah, I did some work with them. It was really interesting. And Azure and Google are coming along there, but Amazon has really got a lead on them in that they are understanding working with the partners. So obviously that's the console and there's the marketplace. And what this is just a marketplace of AMIs. And how this is useful in Cloud DevOps is if you're trying out versions of products, so let's say you're on Tableau or something and you want to go to the next Tableau, go here, grab this particular AMI, as when Paul was showing his AMI for his Nginx. This is an AMI as well, but it is an AMI that is optimized by the vendor. So this is just, it's like a huge tip, basically, when you're using this stuff. And then you can go in and you can see on a manual launch, you go to your particular region, and then this is the, like for Sydney, this is the particular AMI that we're launching, and this just launches an EC2 instance. So, and there are literally 2,000 products in the Amazon Marketplace. And this is a really active area of development around some of their newer technologies like serverless and IoT. So there's going to be other, you know, solutions inside of here. So it's not really a sort of traditional DevOpsy, scripty kind of thing, but it really does help because they have configuration information, they have pricing, you're basically renting this, and you can get up and going really, really quickly. So let me just start the video here, if I can get that going. Let's see, that's the scenario, basically. And, all right, so I'll just start talking through it. So I'm going to show you what this looks like in the console. Everything that I'm doing can be done in Sydney. I think it's really important to show people in a geography things that you can actually do on the cloud in that geography. It must be really frustrating to see services that you can't use. I know I was in one demo and I was trying to localize it and the products weren't available. So we're going to use Redshift and we're going to use S3. We're going to first set up our IAMs. So IAM is the most particularly incorrectly done area that I see on a consistent basis. And as Paul said, if you're going to go on the Amazon cloud, you really, really need to properly understand your IAM security. I am not a security expert. I have yet to find in 3 years a customer who has it set up correctly. It's quite scary, actually. Like he was talking about people checking in their keys and everything. So this is a policy a document, and these are users and roles. Again, I see people doing policies with stars in them all the time. So all resources, just real obvious things. So in the best possible world, you're going to want to have security training and a security audit. So once you do that, then you need your key pairs. Those need to be properly secured, like Paul was saying, very, very important. I see these, you know, copied to all the developers all the time. You're going to want to associate some elastic IP addresses. Those are your public IPs. You pay for those in Amazon if they're allocated but not associated. And then you want to set up your VPCs. This is very similar. Again, just setting up your infrastructure to set up the data warehousing scenario and properly restricting. The last production situation I'm in, which is an IoT, we actually had 5 days of security training, and then we're going to come and have security audit. I would tell you, particularly around data scenarios, and most particularly around IoT, they're actually becoming targets. Somebody put up a Redshift instance in that environment and didn't properly protect it through the security groups, and it was hacked within 2 hours. Yeah, Bitcoins. So really, really important. So this is just showing your security groups, which is basically your firewall, your inbound, your outbound rules. So my take on this, assuming most of you are developers, although there might be some DevOps people in here, sorry developers, this is not a part-time job. This is a full-time job. And I should not be able to hack all these Amazon sites. You know, I'm a suburban mom who started computing in middle age. Do you know what I mean? People who are really serious are gonna do bad things. So, you know, these are all the things that you're going to be setting up, all your security groups. So this is the infrastructure before you start. You need your VPCs. Now I'm going over to the marketplace. I'm grabbing the Matillion image for Australia, reading the security setup, which is just a single EC2 image, but you can scale it just like, you know, SSIS on SQL, where you can have partition the distribution into your data warehouse. And you can use this gives you recommendations around the proper size instance too and the proper type, which is also something I see done wrong in a lot of data scenarios. People will use the wrong type of EC2 image and have really crappy performance. This is all recommended by the vendor. So it can save you a lot of time. So this is showing the setup, EC2, and then you have a public IP, which you associate once you're properly secured, so you don't end up having somebody Bitcoin mine. And your proper security. Notice it's associated to security groups. Then this is what Matillion looks like. So it's a GUI-based interface. Again, it's been a real time saver. The first Redshift that I worked with, I wrote all the scripts to load everything. And it generates a JSON output, which can be checked in its configuration as well. So now I'm going over to set up my Redshift instance, which again, if you're not familiar, it's equivalent, similar to SQL Azure Data Warehouse. SQL Azure Data Warehouse went GA 2 weeks ago. I did take a look at it in preparation for this talk. It looks like a good product. The reason I didn't include it is because Redshift has been in market for 3 years. And I would need to do more testing before I could feel comfortable. It looks good though for Microsoft. I mean, looks good, looks good. Just saying. From a Google standpoint, while this is coming up, I will use a product called BigQuery sometimes, which is literally SQL query as a service. They abstract away the server implementation. A lot of people kind of get freaked out by it because you have no control over the servers underneath at all. You literally just put in a SQL query. You have to upload your data to Google. But I do use that as well, and it's a very good product. So this is just showing where I'm going to put my templates in my bucket for CloudFormer. And inside of here, where am I going? I'm going back to Matillion. So I'm going to show a bit about Matillion here. So you just get to the public IP address, properly secured to your, so only you can connect. Matillion's very sophisticated. It's Redshift native. It will automatically detect your Redshift instances, which is really cool once you have the proper security set up. Very easy to use. It's really a beautiful product. It was really cool. It's really cool to discover a great product and help people become successful. Do you know what I mean? It was really kind of a neat thing. So they have the configuration components, and then they have the transformation components. And they're smart components. They're also extensible. So they're going to create a developer marketplace. So if you guys are really into this and you wanted to sell components, because they're really doing quite well. Very usable, nice interface. Very much like an ETL tool. I'm assuming most of you know SSIS, so very similar to SSIS. And the guys have a SQL Server background, so they kind of built it in mind. But it is Redshift aware, which again helps you. Like Redshift has the way that you load it is important around sort and distribution keys because it sets up the proper fanning of the data. And this product is aware of that. So this is just showing you some of the transformations. And you can chain jobs. It's transactional. So it's a pretty cool product. And again, I don't work for Matillion. It's just I happen to use this one. I've used Talend on here. One of the cool things about this type of scenario is you can spin up and spin down using the marketplace, and you can do bake-offs. You know what I mean? I do that really, really frequently with customers. And to be inclusive, Azure and Google Cloud have marketplaces, and they are growing them. They're just not as, they don't have 2,000 people in there. So this is just going on a bit. It's showing now they're integrating with not only Amazon services, but I think you can do Twitter and Facebook and everything else in here. So let me just skip this up a little bit because it's kind of a lot of Matillion. All right, they're showing you the credentials. And again, You can version, this is a JSON, so it's configuration. You can bring it in, bring it out. Let me skip up a little bit more. Skip up. You can sample your data. There's the admin thing. Okay, so now this is Yellowfin. So probably most of you guys use Tableau in here. That's the most common thing, or PowerBI. So this is similar to a PowerBI. It happened to be based in Melbourne, so I thought I would try to help a local company. They're good, solid guys. Same thing. You just do an AMI and bring it on up really quick, follow their instructions, connect. And so I'm going to skip up just a little bit here. EC2, blah, 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 and then you have this beautiful dashboard that's drillable, embeddable, so on and so forth. And I mean, you will impress your boss if you set up an end-to-end data warehouse in 2 hours. You will. You will. I worked with one company in the middle of the United States. They had been trying to write scripts and do all this stuff manually, and we literally did it in 2 days, and the guy got promoted. Like, I'm not making it up. It was great. So it's all good. And this just shows how it connects natively. Because of the popularity of Redshift, there are a number of visualization partners that just connect natively and will be cognizant of the aggregates and all the things that Redshift does, and just can allow you to produce beautiful dashboards really quick like. So that's kind of the scenario. So I know we want to do some of the DevOpsy stuff here, so let's kind of go up through that. So now that goes all the way up to, there's your end-to-end. Okay, that's what it looks. This is CloudFormation. So I'm assuming most people in here have not seen this. Anybody seen this before? Well, of course, right? Okay, of course. So this is a tool that's included with Amazon, and this is the CloudFormation Designer, which although looks like it might be kind of great, I'm going to say on the video is very hard to use, okay? It's very hard to use, so I hope the team continues to take the usability feedback. What it allows you to do is you drag items on and you can model. What I realistically do is I build, and I do what I did in here. I hand build my environment, and then I use a CloudFormation template that spins up a tool that captures your current environment and creates a JSON template that you can then use. That is how I actually do it. What I wish I could do, I wish I could comfortably just drag on here and model like an architect. But the usability is a little bit clunky. I don't know if you find it that way too? Yeah, so anyway. So this is the output of what it looks like. So the tool is actually a CloudFormation template. It's an EC2 instance. It's a website. So if you go to CloudFormation the first time and you don't have anything spun up, you say, I want to spin up this wizard, basically, and that's what it looks like. And it's a stack. It's an Amazon stack, if you will. And then you go here, and it goes to a website, and you just click through and you say, what do you want to capture from the current infrastructure? And that's how you generate the template. So it's not super sophisticated because, it's included, it's free, but it is usable, right? And it's a basis for working with Amazon configuration as code. And I don't know, do you ever use this as a basis for your stuff, or you don't use it anymore?
I used to use it a lot.
Yeah, you've moved kind of beyond it. Yeah. But when you're just getting started, yeah, it's a good way to start, right? Because you can check in your JSON code and you can diff it, like some of you guys were talking about, to diff your environments. Now, I actually don't know in Azure how this works. I assume there'd be something with PowerShell. And with Google, they are still coming along with this. So, my experience is more in the Amazon world, but it's just my lack of working with Azure as an automated level. It's something I need to kind of probably take a look at. So you can see you just click through and you just say, what do you want, what do you want, what do you want? And then when you get to the end, it gives you a JSON template. And that is something that is executable and diffable. Does that make sense? Okay. So that being said, I'm just going to skip up. There is your template. And there they've got the sample templates inside of it. And there, if you want to open your template. So I made a template of the existing environment. And then I'm just going to open the template, and that's how I loaded that picture up. Does that make sense? I'm not as fancy with my scripting as this fine gentleman, but mine is more, I don't know.
Well, that's a diagram.
Replicatable. Well, okay, mister, it does have a template behind it.
No, what I mean is that's actually really useful to look at and read rather than...
Yeah. So in addition to that, I made a bunch of, and I think I'll just skip over to here. I made a bunch of scripts, and because kind of in the old-fashioned world, we script. So I checked all this in, and this is kind of the world that I'm in with the enterprise, where I'm teaching them CloudFormer and evaluating tools. So we are doing a lot of scripting for DevOps automation. So I wanted to show you a tool that I just really love for Amazon. That is, Amazon has a Labs, a GitHub site. So it's on Amazon Labs. So you have the regular CLI, but if you go AWS Shell, it's just one of those little things that makes your life so nice because it has autocomplete. And you can just say, whatever it is you want to do, like allocate hosts. And it helps you, right? And because you're spending a lot of time writing these scripts. And this is my tool of the day. It's a very simple thing, but it really helps me to more quickly write CLI scripts. And so when I was developing my scripts, I used this pretty extensively. I don't know how great it works on a Windows machine because I don't have a Windows machine, and somebody at work had a problem with it. But it works pretty seamlessly on here. So in any case, honestly, that's really the majority of what I had to present. I'm trying to think if there's anything else I want to talk about. I really wanted to leave a little bit of time for questions because, like I said, I do have this unique perspective of I work with all 3 cloud vendors realistically. And you can get my opinion on that. Go ahead.
Do you see anyone that's dual or tri-hosting? Oh, sorry. Do you see anyone that's dual or tri-hosting? So do you see anyone that's hosting in Azure? Same thing in Azure.
Oh, do I have customers?
And
do I have customers?
Yeah,
that do
you
that?
don't have to say names, but I'm just interested.
Yeah.
And
yes.
their experience in it.
Yes, I do.
Yes.
So what I see, and this is in I would say the hot startups in what's called Silicon Beach, because I live in LA, and so there's a startup sort of area north of the airport there that Google has moved to. A lot of people are moving from Silicon Valley because the rents are too expensive. So Google, Facebook, Microsoft, a whole bunch more. So I see people will be on Amazon, and then they will add Google services for big data. Google BigQuery is a really powerful service. It literally is query as a service. It almost scares people because it's a query window. You type in a SQL query, and bam, you can just process extreme amounts of data. So that's the biggest one that I'm seeing now. Google has added. They hired Nikhil, who built some of the SSIS stuff in Microsoft, and they built a data flow pipeline. But it's all, there's no visual aspect to it. You have to write code. And so you have to be a pretty hardcore programmer because you have to write all your components. Yeah, I know. Present company, right? But I'm seeing people do that because the Google data services are really, really cheap. Google Cloud in general is super cheap to use, but difficult to use. You have to have high level of programmer chops, and their documentation is utter crap, and they don't maintain it, and it makes it very, very difficult. And they're aware, but they don't seem to fix it, right? But personally, I use the Google Cloud for all of my projects because it's the fastest. They pre-warm their VMs. I did some perf testing for Aerospike, which is a Redis competitor, and it's like when you fly first class. I can't tolerate latency on VMs anymore because Google's VMs or GCE VMs and their containers are pre-warmed. So they come up in milliseconds. The fastest VMs for Windows are on Google Cloud Engine, Google Compute Engine.
Are they Docker containers under the hood?
Probably. They don't release the implementation. So the other thing that's really interesting is I think the data wars in cloud are not about storage. I think storage and now even compute with serverless are becoming loss leaders. And I think the wars are around value-added data services, data warehousing, and really the hottest place is machine learning. And what's really interesting to me is how the 3 vendors have had 3 different approaches to machine learning. So Amazon is kind of the everyman. Like, I'm a developer and I just want regression or classification because clustering is too much for me. You know what I mean? And I'm that person. So I've used Amazon machine learning. It's very, just let's get it done, okay? Microsoft has well, you have to hire a team of data scientists because you're the enterprise and that's how you do things, right? Which that has applicability too, because their ML for data scientists is really, really powerful. But I think you have to be a working data scientist to actually get value out of it. What has been super interesting is how Google has slowly started releasing their ML as a service that's pushed by vertical. And this is very quiet. Their speech API, their vision API, their sentiment API. They kick butt. They kick butt. I was talking to a guy last night who's doing a translation app for local people or something like that. And I said, Google would probably want to work with you in the translation API because they know they're very interested in this particular space. And of course, they're very good at it. They've been doing it for years. So to me, it's the really super exciting time to work in the cloud. And my take on DevOps is utilizing what the vendors have to be able to spin up and spin down proofs of concept very quickly, which is a very architecture-y focus. But there's so many new services that if you can quickly compare and try them out, you can really be providing value to your customers and your company. So it's a little bit different, and that's why Paul and I decided to team up because, to me, he's the day in, day out, the better work, don't call me at 2 a.m. kind of guy, right? And I'm the which new fancy shiny thing should you buy, right? And there's DevOps in both parts. So I think that's what we were trying to convey, pretty much. So that's really all I have. We've gone over time a little bit. Do you guys have any questions? Yeah.
Okay, let's say you have a startup and the most important things for you is the speed and the cost and simplicity. So which one of three that you say?
Do you have Python developers?
No.
What kind of developers do you have?
Just .NET developers.
Do the .NET developers want to work in C#, or are they open to Node and some of the other things?
They're open to Node as well, yeah.
Okay. So what is the volume of the business? Is it going to be terabytes of data, or is it going to be gigabytes of data?
It's going to be a terabytes, but it's not that much. I think it's the e-commerce, so it's just, I don't think
I'd probably go on
Azure.
Azure because tooling integration, language integration, you're going to get up faster. I would do the startup program. Really push your vendors on their startup programs. I don't know how they work in Australia, but in US, Google's coming out really aggressively. You can get $300,000 US dollars credit. Amazon, I think, is 100,000, but I could be wrong. They keep upping it. Do you know what I mean? So really push your vendors so that you get the services free for at least the first year and maybe beyond that. The advantage to Google would be lower cost ultimately. Microsoft, I think, is still ultimately the highest cost, although they're addressing that for the services. But there's also a cost, of course, for the developers, right? And so Microsoft, if you're a .NET developer, that's the lowest cost because you have tooling integration and language integration, and those things matter, right? So I'd probably start on Azure and maybe do a bake-off with Google, just to kind of see, because Google's the total opposite side. Do you know?
Right. Cool, thanks.
Yeah, anything else? All right, well, you guys, thanks for hanging in. Hopefully it was worthwhile. Thank you.